Hi everyone, and welcome to this video on graphing using X-Intercepts. As you can see, it's 6.3 in the academic book and 8.2 in the applied book. Our goals for today include using factoring to find the zeros, which are also known as the X-Intercepts. And then we're also going to find the vertex of a parabola and then graph it. And then if we're given the graph of a parabola, we want to be able to write an equation in standard form. So a little bit of review first off, and that is this. This question says, for each question below, name the type of factoring required to factor, then factor and find the roots. Remember that roots is the same thing as saying solve. So the solutions or the roots, those are the same thing. So this first one says 2x squared minus 6x minus 20 equals 0. And we know that if we can common factor that, which we should always try to do first, we get x squared minus 3x minus 10 equals 0. And at any point you can stop the video and you should actually try to do this yourself, because this is really to get your mind going and review this for yourself. So feel free to stop it, come back and join in and see if you can get these right. So the next thing we would do here is we try to find two numbers that would add to -3 and multiply to -10. Those two numbers have to be -2 and -5 in this case. We could go through and start listing the factors of -10 if we wanted, but hopefully by now you're getting pretty quick with that. And so we get 2, and then we write an x, we write another bracket, and we write another x, and then we write a -2 and a -5 because we have a simple trinomial inside the brackets. This is a simple trinomial, and we go ahead, we do not decompose a simple trinomial, we just go ahead and split it up like that. Well, where do we go from there? Well, now we know that that means 2 can never be 0, so that can't be a possibility, but we know that this means that x minus 2 could be 0, or x minus 5 could be 0. Solving each of those, if I add 2 to both sides, I get x equals +2, and if I add 5 to both sides, I get x equals +5. So our solutions for this particular equation, or the roots of this particular equation, are x equals 2, x equals 5. For the next example that we see, we have 4x squared minus 49, and so it wouldn't be a bad idea to have your factoring flowchart out and be using that. This has only two terms separated by a minus sign, and so it should be pretty evident to you that it should be a difference of squares. Difference of squares. And if it's a difference of squares, remember what we're looking for there is a squared minus b squared equals a plus b times a minus b. And so we want to write this out as the a term all squared minus the b term all squared. And then we can go ahead and factor that. 2x plus 7, 2x minus 7. Now remember that the 2 and the x need to be in brackets, because I see so often that people forget to square the coefficient on the x, and if you forget to do that, you end up with 4x plus 7, 4x minus 7, which is not correct. So we get this 2x plus 7, 2x minus 7, which means that that first factor is equal to 0, or 2x minus 7 is equal to 0. 2x plus 7 equal to 0, we just go ahead and we subtract 7 from both sides, divide both sides by 2, and we arrive at x equals -3.5. Do the same thing for the other one, but in this case we're going to have 2x equals +7. Dividing by 2 gives us x equals +3.5. All right, let's look at the next one here. 3x squared minus 11x plus 10 equals 0. We can't common factor anything out of here, so we need to find two numbers that add to the middle term, -11, and multiply to the first term times the last term, and that's the first coefficient times the last number. So that's 30 in this case. Two numbers that add to -11 and multiply to 30 are -5 and -6. We need to decompose in this case, so we can't just write this out like we did in part A. We need to decompose this, so we're going to break down the 11 into -6x minus 5x. And what we're left with after we common factor out of the first two terms and out of the next two terms, take out the 3x out of the first two terms, it's going to leave us x minus 2. And we take a 5 out of the next one and we get x minus 2. And that gives us x minus 2 times 3x minus 5. If you haven't decomposed properly, you won't get those to be the same, but if you have decomposed properly, they will be the same. That is equal to 0, which now means that x minus 2 is equal to 0, or 3x minus 5 is equal to 0. If x minus 2 is equal to 0, I add 2 to both sides, and if I add 2 to both sides, that gives me just x equals 2. And then on the other one, we have 3x equals, we add 5 to both sides, we get that. Dividing by 3 gives me x equals 1 2/3, or 5 over 3. You could also say it's 1.67 repeated. So those, or 1.6 repeated. Those are the two answers that we get there. And then one last one is this. It looks also like a tricky trinomial, but we hopefully notice something special about the first and last terms. Those are both perfect squares. And so we would expect this to be a perfect square. And we know that a perfect square is in the form a squared minus 2ab. I'd say minus because we have the minus sign after the second term there. Plus b squared. And that gives us a minus b all squared. So all I need to do is check the middle term if it's a perfect square. And let's see, 2 times the a term. The a term is the square root of 9x, which is 3x. And the b term is the square root of 16, which is 4. 2 times 3x times 4 is 24x. That is a perfect square. So we can just go ahead and write that out as 3x minus 4 all squared is equal to 0. Well, if 3x minus 4 all squared is equal to 0, that really means that we have the same factor twice. It's the same thing as that. And so really we only have one solution here. We only have the solution that 3x minus 4 is equal to 0. If I add 4 to both sides, I get 3x is equal to 4 divided by 3, and I get x is equal to 4/3, or 1.33 repeated. So those are the solutions for those, and that's really going to form the backdrop of what we're doing today. So I want you to recall a couple of things here. I want you to recall first that the x-intercepts of some quadratic relations in the form y equals ax squared plus bx plus c can be found by factoring. All right, this is something we haven't really investigated a lot yet. We're going to learn about what to do if they're not factorable in the future, but we can find the x-intercepts by factoring, doing this process that we've done before, just like I did in these examples. The x-intercepts, or zeros of a quadratic relation, or roots, sometimes they're called that as well, y equals ax squared plus bx plus c are the solutions to this. So what you've done is we've let y equal 0, and then we just have the same thing we've just been solving up above. So now what we want to do is we want to graph with 5 key points. We want the vertex. So remember the vertex, we're going to be able to get the h and k value of the vertex. The y-intercept, which is the c value in the standard form. And its symmetrical point. So we're going to use that about the axis of symmetry. And then we're going to use these two x-intercepts, which are the r and the s values, as we'll see in this equation. To find the vertex after the x-intercepts, we could complete the square, or this more efficient method, which we'll go over. The x-intercept, or the x-vertex, as we'll notice, is exactly between the zeros, the x-intercepts. If you add them together and divide by 2, then you get the x value of the vertex, and then you can sub that right back in the equation, and that'll spit out the y value of the vertex. If that all sounded confusing to you, let's do an example and actually see how that works out. Here's our first example. It says find the x-intercept, the y-intercept, x-intercepts, and vertex of this parabola. So the first thing I want to note is the y-intercept is this. C equals -5. That is the y-intercept. And so if we're given something in standard form, that's the first piece of information that we want. The next piece of information we want is the x-intercepts. And so for the x-intercepts, what we're going to do is we are going to let y be 0. It's important you state that just so that it's clear what you're doing here and what you're solving for. So let y be 0. That means that 0 is equal to x squared minus 4x minus 5. And then it's a matter of factoring that. We go ahead, two numbers that add to -4 multiply to -5. Oh, those two numbers better be 5 and 1, and the bigger one needs to be negative. So those are what they are. It's a simple trinomial. So I can just go x minus 5, x plus 1. Now you'll notice here that this is in the form, I haven't highlighted it yet, but it's in the form x minus r times x minus s. Meaning that if we look at this, we should be able to say, well, that means in the first case that r is 5, in this first case, and that s is -1 because it's minus. So minus -1 would mean plus 1. Well, okay, well, how does that actually correspond with what we're actually doing as far as solving this? Well, let's go ahead and solve this and just compare that. if x minus 5 times x plus 1 is equal to 0, that means that x minus 5 is equal to 0, or x plus 1 is equal to 0. If I go ahead and add 5 to both sides, I get x equals positive 5. And if I go ahead and subtract 1 from both sides, I get x equals negative 1. And you'll notice that these numbers that we said for r and s up here are the same numbers that we got when we solved this. And so if we get something into factored form, the r and the s value, assuming that we don't have values in front of the x's here, the r and the s values are the x-intercepts. It's quite fascinating there, as we'll look into this a little more in the future. But we've got 5, negative 1. Those are our x-intercepts. So the last thing we need to do now is find the vertex. And so as I highlighted above, the one way to do that, as we'll do today, is saying the x value of the vertex is those two numbers. So it's x-intercept 1 plus x-intercept 2 divided by 2. And the first one was 5. If I add that to negative 1, divide that by 2, that gets me 4, because 5 minus 1 is 4, so 4 over 2, that gets me 2. And now what I'm going to do is I'm going to sub into the equation. So if I sub that into the equation, what that gives me is y vertex equals 2 squared. I'm just replacing anywhere I see the x, I'm replacing with a 2, minus 4 times 2 minus 5. So this is 4 minus 8 minus 5. 4 minus 8 is negative 4 minus 5 is negative 9. So that tells me that the vertex is at an x value of 2 and a y value of negative 9. It would be good of you to stop the video here, go back, complete the square, and see if you get the same vertex, and you should if you've done it properly. So we've got a vertex, we've got these x-intercepts, and we have this y-intercept. So let's go ahead and graph this and see what this looks like. So x-intercepts of negative 1, positive 5. We have a vertex of 2 and negative 9 down here. And we had a y-intercept of negative 5 right there. Now, we take this axis of symmetry, and as we noted that we can find a fifth point, as we're supposed to graph 5 points to really make this clear. Due to the symmetry here, this is a distance of 2. So go over here, a distance of 2, and we graph another point right there. And then we can go ahead and graph just like that. This is the graph y equals x squared minus 4x minus 5. And that's all you have to do. That's all there is to it. But it's important now that we get those 5 key points. Now some of you would have said, well, can I graph that by putting it in vertex form and then using the a value to vertically stretch it? And then also, I would say absolutely you can. But what we're trying to do here by identifying the x-intercepts is we're trying to figure out exactly where the values are where it goes through the x-axis. And that's very important for a lot of things like business models, throwing something through the air, or a projectile flying through the air, and a whole bunch of other things. And so putting it in vertex form and graphing in that method won't always tell you exactly the values you're looking for. So it's important that we can find x-intercepts, the y-intercept, and the vertex, and all of those things be able to graph on the same graph. So I hope that's helpful. I'm going to pause it and pick up the video with the next example later.